Hello, welcome to my YouTube channel, that is Mechanical Engineering. Today in this video we are going to discuss 50 technical interview questions which are generally asked in the interview of mechanical engineering. So the very first question, what is heat treatment and why it is done? So heat treatment is a combination of heating and cooling processes, and it is basically done to obtain the desirable characteristics. Okay, so the heat treatment can be defined as a combination of processes or the operations in which the heating and cooling of a metal or alloy is done in order to obtain desirable characteristics without changing the composition. So here we do not change the composition. So here you can see an image of heat treatment. So the metal is heated first, metal or alloy is heated first, and then it is cooled under various conditions. And why it is done? So it is done in order to improve the hardness of the material. It is done for softening of the metal, then in order to improve the machinability of the metal, then to change the grain size, and to provide better resistance to the heat, corrosion, wear, etc. So these are nothing but some purposes of heat treatment. Next question, what are the different types of fit? So there are three types of fit: clearance fit, interference fit, and the transition fit. So in clearance fit, there will always a clearance between the two mating part. Then in case of interference fit, there will be an interference between the two mating part. And in case of transition fit, there will either clearance or the interference in between two mating part. Next question, describe briefly the different cold working processes. So we can describe the different cold working processes as bar and rod drawing, then wire drawing, and tube drawing. So in case of bar and rod drawing, the material is pulled against the die so as to get a bar or the rod. Then in case of wire drawing, again the material is made to pass through various dies so as to get a final drawn wire. And in case of tube drawing, again the material is pulled against the die, but in this case either stationary or the moving mandrel is used so as to get the tube. So these are nothing but three different types of cold working processes. Next question, what are the different theories of failure under static load? So the different theories of failure is: number one, maximum principal stress theory, which is also known as Rankine theory. Then maximum shear stress theory, that is Guest or Tresca theory. Then maximum principal strain theory, that is Saint Venant theory. Then maximum strain energy theory, that is also known as Hague theory. Then maximum distortion energy theory, which is also known as von Mises theory. Next question, what are the different types of springs? So here you can see the different type of spring: helical spring, conical spring, volute spring, torsion spring, and lip spring. So depending on the applications, you can use different types of spring. Like lip spring are basically used in case of automobile as a suspension system, and some other springs are also there. They are used depending on its application. Next question, explain the effect of alloying chromium and nickel in stainless steel. So the addition of nickel and chromium increases the tensile strength and increases in resistance to corrosion takes place. So here you can see nickel and chromium in its raw form, and this is one of the applications. So you can see the parts, they are shining because of the addition of chromium and nickel. Next question, mention two types of dislocation. So first we will understand what is the dislocation. So dislocation refers to a break in the continuity of the lattice. Okay, and there are two types of dislocation: edge dislocation and screw dislocation. So the first diagram is for edge dislocation and second is for screw dislocation. So in edge dislocation, one plane of the atom gets squeezed out. So here you can see in the first diagram extra row of atom. So such type of defect is known as edge dislocation. And in screw dislocation, the lattice atom move from their regular ideal position. So in second diagram you can see the lattice atom, they are moved from their regular position. Next question, what are the principal constituents of brass? So the principal constituent of brass is copper and zinc. So in the first diagram you can see the brass, and it mainly contains copper and zinc. And in second diagram you can see the application of brass. Next question, what is Curie point? So Curie point is the temperature at which ferromagnetic material can no longer be magnetized by outside force. So that is known as Curie temperature. Next question, what is the percentage of carbon in cast iron? So here you can see the iron carbon diagram. So in cast iron, the maximum percentage of carbon is 6.67%. In case of steel, it is up to 2%. Next question, if the percentage elongation of a material is more than 200%, it is called as. So such material is called as rubber. Next question, which theories of failure are used for ductile material and brittle material? So there are different theories and they are applicable either to the ductile material or to the brittle material. So for ductile material, theories of failure used are maximum shear stress theory and maximum energy of distortion theory. Okay, these two theories are applicable to the ductile material, whereas for brittle material, theory of maximum principal stress and maximum strain are used. Next question, what does following alloy designation indicates? FG 250. Okay, so what is the meaning of FG 250? So it is nothing but a grey cast iron with tensile strength 250 megapascal. So here you can see in the first diagram the microstructure of grey cast iron. So it mainly consists of graphites, and this is the application of grey cast iron. So it is nothing but an engine block. Next question, how is ceramic defined? So it is a solid formed by a combination of metallic and non-metallic element. Okay, so the ceramic is a combination of metallic and non-metallic element. This is one of the application of ceramic. Next question, give one example of metal classified as per the structure as BCC, FCC, HCP and CCP. Okay, so BCC means body centered cubic structure. So the molybdenum has body centered cubic structure. So the first two diagram, that is nothing but BCC structure. So 8 elements at the corner and 1 element at the center. Such structure is known as BCC. Then next two diagram, that is FCC, face centered cubic. So it is found in aluminium. So the 6 atoms at the faces, okay, and 8 atoms at the corners. Such structure is known as FCC. Then HCP, last two diagram, that is hexagonal close pack structure. So that is found in zinc. And the last one, that is CCP, that is cubic dose packed structure. It is found in copper. Next question, what is allotrope? In what form of cubic pattern iron exists? So some element exist in more than one crystalline form. Each form is known as allotrope. And iron exists in two cubic form. Okay, that is BCC and FCC. Next question, what is the difference between isotropic material and homogeneous material? So in homogeneous material, the composition is same throughout. Such material is known as homogeneous material. And in isotropic material, the elastic constant are same in all direction. Such material is known as isotropic material. Next question, what is the difference between column and strut? So both column and strut carry compressive load. Okay, column is always vertical, but the strut as a member of structure could carry axial compressive load in any direction. So here you can see the column, that is a vertical member, the horizontal member, that is a beam, and the beam is supported with the help of strut, right? So both column and strut will carry the compressive load, but column will always carry axial compressive load, whereas the strut, which is an inclined member, it carry the compressive load in any direction. So that is the difference in between column and strut. Next question, what is the difference between basic hole and basic shaft? So basic hole is one whose lower deviation is 0. Okay, so the basic hole is one whose lower deviation is 0, whereas the basic shaft is one whose upper deviation is 0. Next question, what is pyranometer? Okay, what is pyranometer is used? What for the pyranometer is used? So it is used to measure total hemispherical solar radiations. So for measuring the solar radiations, we can use pyranometer. Next question, what is the difference between brass and bronze? So brass is an alloy of copper and zinc, whereas bronze is an alloy of copper and tin. Next question. What is the effect of addition of zinc in copper? What is the use of 70-30 brass? Okay, so by addition of zinc in a copper, tensile strength and elongation we can increase. So by adding zinc in a copper, we can increase its tensile strength and its percentage elongation. And the 70-30 brass has excellent deep drawing property and it is used for making radiator fins. Next question. What for admiralty brass use? So it is used this brass with 29% zinc and 1% tin has good corrosion resistance and it is used for condensers and heater tubes. And aluminium is also added to the brass to improve its corrosion resistance. Next question. What for zinc finds application? So galvanizing, that is the best application of zinc. So the galvanizing consumes the larger proportion of zinc. It is nothing but a surface treatment. Zinc is resistant to the corrosion, but it is attacked by acid and alkalis. Zinc alloy are suited for making die casting since the melting point is reasonably low. Next question. Whether entropy is intensive property or extensive property. Okay. So we can classify the thermodynamic property in two categories, intensive and extensive property. Intensive property are dependent on the mass of the system, whereas extensive property are depend on the mass of the system. So intensive property are independent of the mass of the system, whereas extensive property are depends on the mass of the system. So the intensive properties are pressure, temperature, density, concentration, melting point, boiling point, surface tension, viscosity. These are nothing but the intensive property which are independent of mass of the system. Whereas extensive property which depends on the mass of the system like mass, volume, internal energy, heat capacity, enthalpy, entropy, energy, Gibbs energy. Okay, so the entropy is nothing but extensive property. Next question. What are the name given to the constant temperature, constant pressure, constant volume, constant internal energy, constant enthalpy and constant entropy processes? So these are nothing but different thermodynamic processes. Okay. So the constant temperature process, this is also known as isothermal process. So in isothermal process, you will have constant temperature. Then the constant pressure process. So the constant pressure process is also known as isobaric process, in which the pressure will be constant. Then constant volume process, that is also known as isochoric process, in which volume will be constant. Next process is constant internal energy. This is also known as free expansion process. Then constant enthalpy, this is known as throttling process, and constant entropy process is known as adiabatic process. So these are nothing but different thermodynamic processes. Next question. Why entropy changes for a reversible adiabatic process is 0? Why entropy change for a reversible adiabatic process is 0? Because there is no heat transfer in the process. In reversible adiabatic process, there will be no heat transfer, and that is why entropy change is 0. Next question. When maximum discharge is obtained in a nozzle. So the maximum discharge is obtained in a nozzle at a critical pressure ratio. Next question. What is the difference between hard and soft water? Answer is hard water contains excess of scale forming impurities and soft water contains very little or no scale forming substances. Next question. Which two element in a feed water can cause corrosion of tubes and plate in a boiler? Okay, corrosion is a very predominant phenomena that found in a boiler and that we have to avoid. And two main elements are responsible for it, that is acid and oxygen. Next, while large boilers are water tube type. So here you can see a water tube type boiler. So the water will flow inside the tubes. So water tube boiler raise the steam fast because of large heat transfer area and positive water circulation. Thus they respond faster to the fluctuation in demand. So there is the water tube boiler raise the steam fast because of large large surface area for the heat transfer. Next question. Why consumption of lubricating oil is more in two-stroke cycle petrol engine than four-stroke cycle petrol engine? So earlier there were two-stroke engines. Nowadays the two-stroke engines are banned, and you can find the four-stroke engine everywhere in bikes and moped also. So in two-stroke engine, lubricating oil is mixed with the petrol, and thus some lubricating oil is blown out through the exhaust wall by scavenging and charging air. There is no such wastage in four-stroke petrol engine. So in four-stroke engine, we do not add oil with the petrol. Okay, so that is why the consumption of oil is more in case of two-stroke engine. Next question. How engine design needs to be changed to burn the lean mixture? So there are two types of mixture, rich mixture and lean mixture. Rich mixture contains more amount of fuel, whereas lean mixture contains more amount of air. So how engine design need to be changed to burn the lean mixture? So engine to burn the lean mixture uses high compression ratio. So very first thing, we can use a high compression ratio engine. Then the highly turbulent movement of the charge is produced by geometry of the combustion chamber. Again, you can change the geometry of the combustion chamber, and with that you can burn the lean mixture. Next question. Why piston are usually dished at the top? So here you can see the dish piston, right? The piston are usually hollowed at the top too, to provide greater space for the combustion. So with such design, we can provide the more space for the combustion, increase the surface for flue gases to act upon. Again, we can increase the surface area, then better distribution of stresses. So as we increase the area, again the stress will be distributed properly. Next question. Define ductility. So it is a property of a material enabling it to be drawn into the wire with the application of tensile force. So here you can see a copper metal in its raw form, and we can convert that copper metal, the raw form of copper metal, into the copper wires because of the ductility property. Define fatigue. When a material is subjected to the repeated stress, it fails the stress below yield point stress. Such type of failure is known as fatigue. So whenever the material is subjected to the repetitive stresses, okay, like the same material is subjected to the tension and then the compression, tension, compression alternately. In that case, that material will fail below its yield point, and such type of failure is known as fatigue. Next question. Define factor of safety. So the ratio of maximum stresses to the working stress is known as factor of safety. The ratio of maximum stress to the working stress is known as factor of safety. And generally the factor of safety is kept in between 3 to 6. Next question. Define endurance limit. Endurance limit is maximum value of completely reverse stress that the standard specimen can sustain an infinite number of cycles without failure. That is known as endurance limit. Next question. What is impact load? So the generally impact load is applied during Charpy test or the Izod test to determine the toughness of the component. Okay. So if the time of load application is less than 1/3 of the lowest natural period of vibration of the part, it is called as impact load. Impact load is also known as sudden load or the shock load. Next question. What are the various phases of design process? So the phases are recognition of need. So first of all, you have to carry out a market survey and find out the need of the product. Definition of the problem. Based on the need, you have to define the problem. Synthesis, then analysis and optimization, evaluation, and finally the presentation. For presentation purpose, the various softwares like AutoCAD, Pro-E, CATIA can be used. Next question. What are the different types of load that can act on a machine component? So the different type of load that can act over the machine components are steady load, which is also known as dead load, variable load, which changes with respect to time, shock load, that means suddenly applied load, and the impact load. Next question. What are the types of variable stresses? So the types of variable stresses are completely reverse or cyclic stresses like tension, compression, fluctuating stresses, then repeated stresses. Next question, what is Poisson's ratio? It is a ratio of lateral to the linear strain. So linear strain, that is change in length to the original length, whereas lateral strain, change in diameter to the original diameter. And the ratio of lateral strain to the linear strain is nothing but Poisson's ratio, and its value is generally 0.3. Next question, what are the types of fracture? So there are two types of fracture, ductile fracture and the brittle fracture. Next question, define stress concentration and stress concentration factor. So the stress concentration is the increase in local stresses at the point of rapid change in cross-sectional or discontinuities. So due to change in cross-section, the stresses will increase rapidly. That is known as stress concentration. Stress concentration factor is the ratio of maximum stress at the critical section to the nominal stress. Next question, what are the factors to be considered in the selection of material for the machine element? So the factors are required material properties, then manufacturing ease, material availability, and the cost. Next question, give some method of reducing stress concentration. How you can reduce the stress concentration? So it can reduce by avoiding the sharp corner, then providing fillets, that means providing the radius, then use of multiple hole instead of single hole, then undercutting the shoulder parts. So with this method you can reduce the stress concentration. Next question, define machinability. So it is a property of a material which refers to a relative ease with which a material can be cut. It is measured in a number of ways, such as comparing the tool life for cutting different material. So this is known as machinability. Next question, what is gear ratio? So it is a ratio of number of revolution of the pinion gear to the one revolution of idler gear. That is known as gear ratio. Next and the last question, what are the difference between pneumatic and hydraulic? So in pneumatic, air is used as a working fluid, whereas in hydraulics, oil can be used as a working fluid. Then pneumatic power is less than the hydraulic power. Then the pneumatic components are generally smaller as compared to your hydraulic components. Then leakage. So leaks in hydraulic cause fluid to be sticking around the components. Okay, as we are using oil, so that oil may stick to the outer surface of the system. Whereas air, if the air is get leaked from the pneumatic system, then it will go in the atmosphere. Then pneumatic obtain power from the air compressor, while hydraulic requires a pump. Then air is compressible, whereas hydraulic oil is not compressible. So that is the differences between the pneumatic and hydraulic system. So thanks for watching my video. Thank you.